This video covers Module 6, Part 4, which is about solving equations with rational expressions. Before, we'd just been working with rational expressions. We'd been adding, subtracting, multiplying, dividing, simplifying. Now we're going to see equal signs. Now we're actually solving an equation. We're going to find specific x values that'll make our equations true statements. So please make sure you're completing your guided notes as we go along. So the first thing we need to make sure we're finding is the domain of our rational equations, reminding ourselves that we can never divide by 0, right? So what I need to do is I need to look for the overlap of all the domains of each term or rational expression in my equation. So I'm going to take all of my denominators and set them equal to 0. I have x equals 0. 2 equals 0, that doesn't make any sense, I can ignore it. 2x equals 0, which would give me x equals 0, right? So my domain of this function would be all x values as long as x doesn't equal 0. And the reason I need to know this is if I solved this first equation and found that x equals 0, that would mean there's no solution. And we're definitely going to see an example of that in today's video. For problem 2, I need to set each of my denominators equal to 0. I've got x minus 3 is 0, x plus 3 is 0, x squared minus 9 is 0. So I find that x is 3, x is negative 3. I could then factor, right? Whenever we see a degree 2, we're going to want to factor, but I would also get that my denominator couldn't be 3, and it can't be negative 3. So in this case, my domain is all real numbers of x as long as x doesn't equal negative 3 or 3, because those two values would make me have to divide by 0, which we don't want to do. So let's practice solving these two equations. Specifically, we're going to use these as our first two examples since we already know their domains. So for my first step when I'm solving rational equations, I need to find the domain, and we already found that the domain of x is everything as long as x doesn't equal 0. I'm then going to multiply by the LCD in order to eliminate my denominators, and then we'll solve and check that each solution is in the domain. It could be the case that we have more than one solution, so we're going to need to check them. So what's the LCD of x, 2, and 2x? Well, that's going to be 2x. So if I multiply both sides by 2x, on the left-hand side, I get 4x over x minus 6x over 2, because we're distributing that 2x, equals 14x over 2x. Now what I need to do is simplify each of my fractions, and that'll eliminate my denominators. In my first equation, the x goes away, so I have a 4. 6x over 2 is 3x. 14x over 2x, that's going to give me a 7. So now I have an equation of one variable. I know how to solve this. I subtract 4 from both sides. Negative 3x equals 3. So I divide both sides by 3 and get x equals negative 1. This is my solution. Is it in my domain? Yes, because only 0 is not included in our domain. So our solution here is x equals negative 1. Let's do another example. We found the domain of this expression earlier, and we found that as long as my x doesn't equal negative 3 or 3, those could be our possible solutions. That's our domain. So in order to solve this, I need to multiply by the LCD. Well, the LCD here, I've got x minus 3, x plus 3, and it sometimes helps for us to visualize this if I factor my denominator. So instead of having, I guess I erased that so soon. Instead of having x squared minus 9, I'm going to write that as x plus 3, x minus 3. And I hope that we'll be able to see that that's going to be our LCD of x minus 3 and x plus 3. So let's multiply both sides by my LCD. On our right-hand side, we can see that my numerator, when I multiply by the LCD, my entire denominator is going to go away. So I have just 12. If I multiply by x minus 3, x plus 3 on the right, I'm going to have 2 x plus 3, x minus 3 over x minus 3, minus 3, x minus 3, x plus 3 over x plus 3, because when we multiply fractions, we only multiply the numerators. And we can see that my x minus 3s are going to cancel out, and my x plus 3s are going to cancel out. So I'm left with 2 times x plus 3 minus 3 times x minus 3 equals 12. Now I have an equation, one variable. I need to distribute and solve. So I went ahead and distributed my 2 and my negative 3. I can now combine like terms. I can move my constant to the other side, right? Everything after this first step, right, should be skills from module 1. So x is 3. Well, is 3 in my domain? No, 3 is not in my domain. It's one of my excluded values from my domain. So this has no solution because 3 is not in our domain. Let's do 2 more examples. So I have 3 over p squared plus p minus 2 minus 1 over p squared minus 1 equals 7 over 2 times p squared plus 3p plus 2. I need to factor all of those denominators so I can figure out what values are excluded from our domain. And we're going to ignore this problem for now and just focus on solving the top one. I should have broken these up. So I have 3 over p plus 2 times p minus 1 minus 1 over p plus 1 p minus 1, because this is a difference of squares, equals 7 over 2 times p plus 2 times p plus 1, because 2 times 3 is 2 and 2 plus 1 is 3. So my LCD is going to have one of every single terms that we see. So I'm going to need a p plus 2 and a p minus 1 and a p plus 1. Well, I already have a p minus 1 now. I'm going to need a 2. I've got a p plus 2 and a p minus 1. So now everything is included. This is our LCD. It's a big LCD. So we multiply by our LCD on the left and on the right. And I hope we see on the right here that my 2 is going to cancel, and my p plus 2 and my p plus 1. So I'm going to be left with 7 times p minus 1. On the left, I need to multiply by my LCD as well. That's going to give me such that in my first term, my p plus 2s are going to cancel. So I have 3, no p plus 2 because that canceled there. No p minus 1, but I've got a 2 and a p plus 1. Now I have to look at my second term. I have minus 1 over p plus 1, p minus 1. Well, my p, for this example, my p plus 1 and my p minus 1 are going to cancel. So I'm left with 2, 1 times 2 is 2, times p plus 2 equals 7 times p minus 1. Now I can combine my like terms. So I have 6 times p plus 1 minus 2 times p plus 2 equals 7 times p minus 1. So I have 6p plus 6 minus 2p minus 4 equals 7p minus 7. And I can combine like terms, so I have 4p plus 2 is 7p minus 7. I subtract 7p from both sides, so I have negative 3p. Subtract 2 from both sides, so I have negative 3p is negative 9. P equals 3. And I need to make sure that's in my domain. Well, the values that are excluded from my domain, well, when p is plus 2 is 0, that'd be p is negative 2. When p minus 1 is 0, that'd be p is 1. And when p plus 1 is 0, that'd be when p is minus 1. So those are the three values excluded from my domain. This can be my solution. Let's go ahead and take a look at this second equation. We can ignore this first one. So I have 2 over 3x plus 1 equals 1 over x minus 6x over 3x plus 1. So my LCD is going to be 3x plus 1 times an x, because I need each of those terms to be present. So I'm going to multiply by x times 3x plus 1 on the left. Those 3x plus 1s are going to cancel, so I have 2x. On the right, and I can do this long ways so we can double check that we make sure we know what's going on. I'm going to have x times 3x plus 1 over x minus 6x times 3x plus 1 over 3x plus 1. And then I can see what simplifies. My x's cancel here. My 3x plus 1 cancels here. So I'm left with 2x equals 3x plus 1 minus 6x squared. And I can move everything to the left-hand side so I can set it equal to 0 and factor. We're going to add 6x squared to both sides. We're going to take away 3x from both sides, and we're going to subtract 1. So I have 6x squared minus x minus 1 is 0. Now I need to factor. Well, what are the factors of AC that add up to B? AC is negative 6, B is negative 1. How about negative 3 and 2? And because my A isn't 1, I can't use the shortcut. So I have 6x squared minus 3x plus 2x minus 1 is 0, and we factor by grouping. The greatest common factor of 6x squared and a negative 3x is 3x. The greatest common factor of 2x minus 1 is a 1. I collect my greatest common factors and what they left behind, and I set each of my terms equal to 0 to find my solutions. I get 3x is negative 1, so x is negative 1/3. And I get 2x is positive 1, so x is 1/2. Are these in my domain? Well, what's my domain? Well, I can't have x equal to 0, and I can't have 3x plus 1 equals 0, which means I can't have 3x equal to negative 1 or x equal to negative 1/3. So x can equal 0 and x can equal negative 1/3. Well, what are my solutions? I have negative 1/3 and 1/2. So negative 1/3 is not a solution because it's not in my domain. My only solution is going to be when x equals 1/2. For the last two examples of this video, we need to practice solving rational functions for a specific variable. Again, we're just going to be multiplying by the LCD. So for our first example, I have solve 1 over f equals 1 over p plus 1 over q for p. So my LCD is going to be all my denominators. It's going to be f, p, q. That's what I'm going to multiply by on both sides. That gives me fpq over f equals FPQ over P plus FPQ over Q. Well, my F's are going to cancel, my P's are going to cancel, and my Q's are going to cancel. So I have PQ equals FQ plus FP. And I need to solve this for P, so I have to get my P's together. I'm going to subtract FP from both sides. So I have PQ minus FP equals FQ. I can then factor out a P. And then I could divide both sides by Q minus F. So my final answer would be P equals FQ over Q minus F. Final answer. We're going to do something very similar for problem 2. So make sure you've copied this down. You might want to pause to make sure you've got all the steps. So if I have I equals NE over R plus N little r, and I want to solve this for N, the first thing I need to do is multiply by the LCD, which is my denominator. So I multiply both sides by R plus NR. That gives me IR plus INR equals NE, because my denominators will cancel. I'm trying to solve for N, so I need to get my N pieces together. Both of these have an N in them. So I have IR is NE minus INR. I can factor out an N and divide by E minus IR. So for my final answer, we'll put it up top. I get that N equals IR over E minus I.